we got to understand the term Phasor diagram. So this is an example of Phasor diagram. So we have two rotating vectors and they're going around. Based on certain aspect of there, we are able to plot a sinusoidal wave. Now in this video, we're looking at relating those two rotating vectors. So there are few terms that will relate the two vectors. So those words are in phase and out of phase. Now, it's kind of common sense, but let me put it across to you guys as question. Is this particular scenario in phase or is this in phase? Is one in phase or two in phase? With respect to the red, the blue vector, when is it in phase? Yes, this particular scenario. So basically when they're overlapping, they're said to be in phase. There's a particular definition, we'll understand that. Let's look at out of phase. Obviously, anything that's not in phase, it's out of phase. So this is an example of out of phase, as simple as that. Here we're looking at out of phase. Now let's define it. When do we technically tell it's out of phase? We can do that with the help of our sinusoidal wave. So look at the maximum of both the graph. Are at different point of time? Right? Clearly they are at different point of time. Or you can look at their minimum. Are they at different point of time? They too are at different point of time, right? How do you find the minimum? Just look at the 0. Just look at your left. Here we have 0. And along this line, wherever the graph is passing, that is your 0. So we can see now the blue is 0. Now the red is 0. There's clearly some gap. So these are said to be out of phase. Now let's look at in phase. So let's look at in phase. That's your in phase. From the Phasor diagram, it's very simple to see. Now let's look at the sinusoidal wave. Can you see that? The time that both are maximum and both are minimum, it's same. Please observe. So this is said to be in phase, as simple as that. Okay, it's not at all complicated. Right? So this is out of phase, this is in phase. And in out of phase, there are two terms that we need to know, lead and lag. Obviously, one will be leading, one will be lagging when they're out of phase. So again, a simple example over here. So in this case, the red vector is leading the yellow one. So let's call that as A, this is B. A is leading B. So if one Phasor reaches its maximum value before the another Phasor, that particular Phasor is said to be leading. So in this, not this actually. In this particular diagram, which is leading, you can clearly tell from the Phasor diagram, which is leading the blue one, right? And look at this sinusoidal graph, which is leading the blue one. The maximum value that the blue one reaches is faster than the red one. Of course, the red one has a lot more amplitude. We're not looking at that. Who reaches fastest? That's what we're looking at. So here, the A is reaching faster than B. So A is leading B. Other way around is B is lagging A. Yeah, that's it.